Hey, everyone. Welcome to Building Universal Permission-Based Messaging in Web3. I'm Naomi. Hi, I'm an engineer here at XMTP. I've been there for a little bit over a year. I wrote our Kotlin SDKs, our React Native SDK, and I maintain all of our mobile SDKs, which includes Flutter and Swift. I worked at a couple of startups, GitHub being my most notable. I was there for 6 years. Aside from that, I have a Bachelor's of Science in Computer Science and Mathematics from Colorado School of Mines, right here in Colorado. So it feels good to be back. My first job was actually at a company called Spire Media here in downtown Denver, where I was writing PHP. I also have a master's degree in animation. So if you're into art, also into art. So why is universal allow and block preferences important? Well, have you ever had that one person who just won't leave you alone? They hound you with DMs on Instagram, they send you messages on iMessage, they somehow get your email, your phone number, and you have to individually go and block them from every single account that you have? Well, I'm here to tell you about how we're solving this in Web3. So what is XMTP? I'm just going to breeze through this in case you're familiar, but XMTP is an extensible messaging transport protocol. It's an open source protocol, network, and standard for secure private Web3 messaging. The way I like to explain it is, think of if you could send messages from Signal to your friends on WhatsApp without having to download the same app to communicate, and by preserving your own privacy from the big centralized companies that run those apps. You own your messaging, and you get to choose which app you want to use. XMTP is a protocol, not another messaging app. With Web 2, messaging is siloed inside each app. I can't send a WhatsApp message inside of Snapchat or a Twitter message inside of Facebook. You don't own your messaging. The apps do. We currently have 6 SDKs, allowing you to add private messaging into almost any app that you could imagine, and a Rust backend that runs the cryptography to help keep things performant. So let's get into the details of allow and block preference-based messaging. So the idea behind this is if you block someone in one place, they are blocked everywhere on the network. So that means if you don't want them messaging you in one app, they can't reach you on a different app. We've done this with 2 levels of security and privacy. We use HKDF to derive a deterministic topic secret from a user's existing identity key. The public topic includes the SHA-256 of the derived key, so users are only able to identify their own topics. Then, to encrypt the block data, we first generate a new key via HKDF from the user's identity key, and then encrypt the message via AES GCM using the derived encryption key and the user's public key as associated data. We do all of this to protect you and who you are blocking. So how does it work? The protocol is set up in a way to allow the storing of any type of identifier. Currently, it supports addresses and group IDs. So you can allow or block an individual or an entire group. So the flow would go like this. A user gets a message from an unknown address. The user can see the message as spam, so they block the address. The app then makes a call to our network to let the network know that this address has been blocked. The network encrypts that data and it publishes it. The user then logs into a different app, and this app now fetches the consent records from the network. They can see that this address has been blocked, so they update the UI accordingly. And the user does not see any more messages from this address anywhere. So it would be essentially like if you blocked someone on YouTube, and now they also are blocked on Instagram. So what about group chats? It turns out that the messaging industry as a whole hasn't really landed on a standard on how to handle this at all. Some apps just hide the user's messages entirely. Others show a dialogue saying the message is hidden. Some don't do anything at all. Seems like you kind of get a mixed bag of what's going to happen depending on which app you're using. There is a solution that we've landed on that has a lot of security guarantees. It's called OpenMLS. It's an open source implementation of the messaging layer security protocol. It's the most secure you can get with messaging, and most of the big messaging apps today don't use it. So XMTP recently released an alpha version of group chat messaging using OpenMLS for the most secure level of messaging. This means we provide forward secrecy, which prevents messages sent today from leaking even if a future compromise happens. Post-compromise security, which prevents messages sent in the future from leaking even if a compromise happens today. Key revocation, which allows users to disable keys if they ever become compromised or are no longer needed. Anonymity of the social graph. This prevents the network from determining which users are communicating with each other. Anonymity of the sender prevents the network from determining who each message originates from. Message authentication, which prevents attackers from masquerading as a conversation participant. Message confidentiality, which prevents attackers from reading the contents of each message. And message integrity, which prevents attackers from tampering with the contents of each message. But our group chat security goes beyond just MLS. We also have allow and block preferences. So the network allows blocking an entire group or just blocking an individual. But it's up to the app to decide how to display that. This means apps can handle this in whatever way they think is best. But we do have a standard that the protocol will recommend. Currently, that is hiding the blocked user's messages in the group view. But an XIP will be open for comment by the community, so we can land on a standard together. The protocol also has admin permissions on groups, which allows some control around who can add or remove people from a group chat. You own your messaging, and you own who can reach you where. This is something that simply cannot be done in a centralized world. Even beyond messaging, controlling who you can reach you or see you in a universal way is powerful. So, in conclusion, universal allow and block preferences offers a powerful solution for protecting privacy but allowing interoperability between applications. I'm really excited to see what imaginative ways universal block and allow preferences are used in a decentralized world, protecting people on all new levels. And you can find us at booth 517 in Privacyville. And I know you probably can't ask questions in this room. So I do have some frequently asked questions that people sometimes ask me that I can go through here. So one question I get a lot is, how many people are allowed in a group chat that we have? Currently, we're capping at 250 people, but it's not for technical reasons. This could increase in the future. Another question I get a lot is, what does alpha mean for group chat, and when will it be ready for production? So we're currently in active development on group chat, which means some things may break. Because of that, we don't have the ability to use groups in production yet, but are working as fast as we can to get to a stable version. We're really looking for a lot of feedback here so we can get to that stable version faster. Another question is, when will you be fully decentralized? We have a roadmap online, but are hoping for springtime for our first level of decentralization. So that's happening quickly. So yeah, if you want to engage or learn more about building with XMTP, here are some of the channels you can find the wider community on. And also look for us tomorrow. We'll be around the hackathon and also in Privacyville. Thank you. Really fast.